Behold, the element silicon. It's number 14 in the table of periodics. The nucleus contains 14 protons and 14 neutrons. We are interested in the electrons, but not all the electrons. We only care about those in the outer layer, which is called the valence shell. This shell can hold a maximum of 8 electrons. Silicon has 4 electrons in this outer shell. Atoms try to be as stable as they can. When you put silicon atoms together in a layer. So if you imagine a single layer of silicon atoms, their valence electrons will be sort of shared amongst them. Each silicon atom still has 4 valence electrons, but it thinks it has 8 because there is another few hanging around. So it is much happier. This sharing of valence electrons is called covalent bonding, and it is very strong. In order to make electronic shit, what we need to do, is diffuse other elements into the silicon. Phosphorus, arsenic, antimony, boron, gallium, aluminum, and aluminium are used in a high-temperature process called doping. Here, one side of the silicon is coated in phosphorus, which has 5 electrons in its valence shell. The other side is coated in boron, which has 3 electrons in its valence shell. Diffusion creates 2 different types of material. Phosphorus produces what they call N-type material, due to the extra electrons. Meanwhile, the boron creates a P-type material because there is less electrons, thus creating the p-n junction. The empty spaces in the P-type material are called holes. Holes are positive, and move. It's like when you start with a hole in the ground, and you fill that hole up with some dirt that you dig out next to it. Effectively, the hole has moved. This is done so that the movement of holes is in the direction of conventional current flow, but here we are only going to consider electron flow. Now, what happens is, the electrons in the N-type layer that are closest to the boundary with the P-type layer see the holes, and the covalent bonds that offer increased stability. The electrons move into the holes in the P layer, and of course, the holes move into the N-type layer. This results in what they call the depletion layer. There is a difference in charge, with one side of the depletion layer being more negative than the other side, which is more positive. Remembering from before, where a difference in charge exists there is a potential difference. In silicon, this is around 0.7 volts. And this depletion layer is what controls the flow of electrons based on the applied voltage. In order for electrons to flow, the applied voltage has to be in the right direction and high enough to overcome the depletion layer. Once the voltage is higher than that, electrons can flow. This is called a forward bias. If the direction of the voltage is reversed, the size of the depletion layer increases, and electrons cannot flow. This is called a reverse bias. So electrons only flows in one direction. All hail the p-n junction. So there.